Okay, so we're asked to analyze the slope of a graph for each of these things. Time in hours versus average speed in mile per hour, number of bird kernels versus number of extra seconds, number of gallons in a trip versus average speed. The whole class, most people did a pretty good job of understanding what the graph was saying, speculating about what the graph might mean, but we were focused on the slope, okay? And so, you know, for pretty good statements about meanings and so forth, I'd give 3 points out of 10 because you're thinking about the graph, and you're not there if you don't do any more than that, but you're on the verge of being there, okay? And being on the verge, well, 3 points out of 10 ain't great, but it's on the verge of making, you know, most of the points or all of them, okay? Okay, so exit time in hours versus average speed in miles per hour. Well, it helps to draw time versus average speed. It doesn't even hurt to put the hours on here and miles per hour here, right? Then it doesn't hurt to put a couple of points in this thing. A picture can be very helpful. Not necessary, but it can be very helpful, right? Because you're doing a slope, it's going to be a fundamental triangle on a graph, okay? And you know that the average speed is going to, that the time in hours is going to go down with the average speed. Most people said that. Very good. Okay? It's everything but what we needed. And yeah, quite a bit. Okay, so you have this, right? Okay, so without labeling it on the graph now, we've got the graph to look at. Rise represents run represents the slope represents. Okay? So on every one of these, that's exactly what we want to do. We want to draw a graph with a couple of points. We know extra bird kernels versus extra seconds, more extra seconds, more bird kernels. So the graph's going to go off somewhere. That's all you got to do. You know, just any 2 points. It doesn't have to be representative of what you think might happen because you don't know the details of what's going on. Number of gallons in a trip versus average speed. Now, depending on your average speed, number of gallons in a trip could go up with average speed or down with average speed. If you're going too slow, you're not burning very efficiently. If you're going too fast, you're not burning very efficiently, right? So there's no set way that the triangle should look, and it doesn't really matter how the triangle looks because you're only saying what it means. You know, if you got the triangle going up and then you find it's actually going down, well, that's okay. Your analysis is still going to be correct because we're not doing the numbers, we're doing the meanings. Okay? One thing you don't want to do is draw a fundamental triangle that doesn't go up or down because you're not sure what it does. Pick up or down, right? Now, since most of us drive like maniacs, more speed is going to give us less mileage. More speed is going to give us more gallons on a trip. Okay? We require more gallons. Okay? Yeah, there's more air resistance. Main factor. Okay? So, you know, graph would probably look like this. We draw this. We draw this. And then we write rise represents, run represents, so slope represents. We write rise represents, run represents, so slope represents, right? Now, if I was trying to make people have a high score, I'd have written all this out for them. That's how you teach people to do something without understanding what they're doing. Although, if you do enough of this, like, you know, if there's a homework sheet that asks you to do this, it might get the procedure. It might actually be helpful. Since I've essentially done this on every problem you've seen me do, and I've done a number of them, I expect you to kind of extract this, okay? So, we can fill this in very easily. Rise represents what? The graph of time versus average speed. What's the rise represent? Okay, I'm not getting a quick answer, so I'm going to talk about it for a minute.
Time of hours.